Jupiter is an invincible gas giant. It affects the orbits of all the planets in the solar system and can withstand a meteorite impact that would destroy the Earth. But what if I told you that Jupiter could be destroyed by life? Even the tiniest living organism brought to the gas giant could be the beginning of the end. In this video, I'll tell you what can change the color of Jupiter and even blow it up. What could the Great Red Spot actually be? And how will life on Jupiter destroy the planet? Jupiter could become infected with life back in April 2003 when the Galileo probe, after 8 years in orbit, headed into the atmosphere of the gas giant. NASA decided to dispose of Galileo to prevent possible contamination of Jupiter's moons with Earth-based microbes. But the fact that they ended up on Jupiter itself didn't bother NASA in the first place. This gas giant is 90% hydrogen. On Earth, this element is almost 2 million times rarer, partially because bacteria annually eat more than 100 tons of hydrogen, which is formed on our planet. NASA scientists just never assumed terrestrial bacteria could survive on Jupiter. But in 2020, 17 years after the disposal of Galileo, scientists at the Massachusetts Institute of Technology, led by astrophysicist Sarah Seeger, unexpectedly figured out how microorganisms would behave on exoplanets. They placed Escherichia coli, or E. coli, and yeast in different environments, including pure hydrogen. And the bacteria not only survived, but also successfully multiplied and formed colonies. If such bacteria were on the Galileo probe, they could have survived. The point is that the probe dived into clouds of frozen ammonia, where the temperature is slightly higher than minus 100 degrees Celsius, and the pressure is the same as on Earth. On Jupiter, bacteria that feed on hydrogen have an endless supply of food and no natural enemies, so their colony will grow really quickly. Meanwhile, bacteria will release methane and hydrogen sulfide. These elements are much heavier than hydrogen. Methane is 4 times heavier and hydrogen sulfide is 8.5 times heavier. And if bacteria processed all the hydrogen on Jupiter, its mass would increase by 4 to 8 times. As a result of increased gravity, the planet would become denser and reduced in size. And since methane and hydrogen sulfide are colorless gases, Jupiter's color would change too. But that's the most optimistic scenario, because once bacteria start changing the concentration of elements on Jupiter, they'll launch much more frightening chemical processes. But what if they're already launched? Galileo is not the only potential source of bacteria on Jupiter. This gas giant constantly faces the attacks of asteroids and comets. For example, in 1994, fragments of comet Shoemaker-Levy impacted Jupiter. Scientists believe that heavy metals appeared in the planet's upper atmosphere after this impact. It may be not just heavy metals, but in fact, microorganisms could have gotten to this gas giant much earlier, when Jupiter was actively devouring other planets. During its mission, the Juno spacecraft discovered that Jupiter may have absorbed a whole other planet back at the dawn of the solar system. It was 10 times the size of Earth and forever changed the axial tilt of the gas giant and its composition. NASA thinks that after this collision, Jupiter became 9% rock and metals. Perhaps it was also when bacteria made their way to it. That would explain, for example, the nature of the Great Red Spot. It may well be the accumulation of purple sulfur bacteria. On our planet, they color the water during red tides. At the same time, purple bacteria can feed on molecular hydrogen and hence multiply in Jupiter's atmosphere. And if the Great Red Spot is indeed an accumulation of bacteria, and the first microorganisms were delivered to Jupiter millions of years ago, it's possible that we'll see the first consequences of their vital activity very soon. and they'll be devastating. Bacterial colonies on Jupiter will gradually convert hydrogen into methane, and this gas is not the most stable. When its concentration reaches 5%, methane begins to explode. And when the methane content exceeds 16%, upon interaction with oxygen, it begins to burn. Since Jupiter's atmosphere is heterogeneous, oxygen and methane can be located in different bands of the planet and create firestorms in places of contact. But the fiery apocalypse won't last long. Under the influence of the sun and lightning, methane on Jupiter will be quickly converted into carbon dioxide and water. However, the gas giant could be home to completely different bacteria. In this case, our planet is in danger. Cyanobacteria have roamed Earth for 3.5 billion years. Thanks to them, our planet gained enough oxygen to support life. They release it during photosynthesis. And if these bacteria hit Jupiter when it swallowed the planet, we don't have long to live. Let me explain. When hydrogen that makes up Jupiter mixes with the oxygen released by cyanobacteria, oxyhydrogen is formed. It'll trigger not just a single explosion, but a whole chain reaction that will destroy Jupiter. And not only Jupiter, the blast wave from Jupiter will reach Earth. The entire atmosphere on our planet will be literally swept away into outer space, and all the oceans will disappear along with Earth's atmosphere. In addition, half of the Earth's crust will change. New volcanoes and fissures will appear on the side facing the explosion. What awaits us is global mass extinction. But the disasters won't end there. The blast wave from Jupiter will reach the Oort cloud at the edge of the solar system, and hundreds of ice blocks will hurtle towards Earth. Moreover, the disappearance of massive Jupiter will disrupt the gravitational balance, and the orbits of all the planets will shift closer to the Sun. But the bacteria won't stop there either. After destroying Jupiter, a blast wave could spread colonies of microorganisms throughout the solar system and even beyond. Sure, survival in outer space can be challenging, but over the years of life on Jupiter, bacteria can evolve and adapt to harsher conditions. First of all, a colony of bacteria will reach Jupiter's neighbor Saturn, and it's more than 90% hydrogen. So Saturn will suffer the same fate as Jupiter. Next, a colony of bacteria will destroy the two remaining gas giants, Uranus and Neptune. But that wouldn't be the end of this dramatic story. You see, our universe is almost 90% hydrogen. It exists both as superheated plasma within stars and as molecular hydrogen in interstellar space. Therefore, the unleashed bacteria will never be left without food. After the solar system, they may head to the Radcliffe Wave, a string of star-forming regions in the Milky Way, and then they may well eat Maggie, the largest cloud of hydrogen gas in the galaxy. In doing so, bacteria will be able to travel great distances in search of a new victim. After all, on Earth, in Antarctica, most microorganisms can be in suspended animation for years without the need for food. So, over millions of years, bacterial colonies could just eat up our entire galaxy. If there was a chance Jupiter's explosion wouldn't wipe out life on Earth, we could be watching microorganisms gradually destroy space.